Welcome back to Snooze to Astronomy. Tonight we will take you through a long and soothing journey about 101 facts about the Milky Way. So lay back, relax, and close your eyes as we take you along this path of transcendence. The Milky Way is our cosmic home, a barred spiral galaxy stretching more than 100,000 light-years across. From our perspective on Earth, it appears as a shimmering band of light cutting across the night sky. But this glowing ribbon is actually the combined brilliance of billions of stars, woven together with gas, dust, and dark matter. To stand beneath its arc on a clear night is to glimpse our place within a vast, interconnected system. At the heart of the Milky Way lies a supermassive black hole called Sagittarius A*, weighing about 4 million times the mass of our Sun, invisible to the eye. Its gravitational pull orchestrates the orbits of stars in the galactic core. Some stars whip around it at thousands of kilometers per second, their dizzying speeds revealing the immense gravity of the dark heart that binds the center of our galaxy together. The Milky Way's disk is not flat like a perfect record, but warped and twisted, shaped by gravitational interactions with nearby galaxies and dark matter. This subtle bending is evidence that galaxies are not static structures but living, breathing systems responding to the forces of the universe. The warp shows us that even our galaxy is sculpted by the pull of unseen neighbors. Our galaxy contains an estimated 100 to 400 billion stars, and possibly as many planets as there are stars. Among these worlds may lie countless Earth-like planets, waiting quietly in their orbits. The sheer scale of potential habitats suggests that the Milky Way could be teeming with life. Though we have yet to confirm our cosmic neighbors, the Milky Way rotates like a colossal pinwheel, with stars and gas completing orbits around the center in hundreds of millions of years. Our Sun, for example, takes about 225 million years to complete one galactic year. This means that since its birth, the Sun has orbited the Milky Way less than 25 times, reminding us how young our solar system is in galactic terms. The spiral arms of the Milky Way are vast rivers of stars and gas that wind outward from the center. These arms are not solid structures, but patterns created by waves of density, where stars and gas cluster together more tightly. As material flows through these arms, it compresses, triggering bursts of star formation that light up the galaxy like fireworks frozen in slow motion. Our solar system sits about 27,000 light-years from the galactic center, embedded in a quiet spur of the Orion Arm. This location is relatively calm compared to the bustling inner regions of the galaxy, providing a stable environment where life could evolve. We live not in the brightest downtown but in the peaceful suburbs of the Milky Way. The halo of the Milky Way extends far beyond the visible disk, a vast spherical region populated with ancient stars, globular clusters, and dark matter. Though faint, this halo contains much of the galaxy's mass, an invisible scaffold holding the spiral disk in place. Within this halo lies the memory of the galaxy's earliest days, a fossil record of cosmic history. The Milky Way is part of a cosmic neighborhood known as the Local Group, a family of more than 50 galaxies bound together by gravity. Our nearest large companion is the Andromeda Galaxy, which is on a collision course with the Milky Way. Billions of years from now, the two galaxies will merge, creating a new, larger galaxy, an epic dance of stars across the universe. Dark matter makes up most of the Milky Way's mass, an unseen presence that exerts gravity without giving off light. It surrounds the galaxy like an invisible cloak, shaping its rotation and structure. Though we cannot see it directly, dark matter reveals itself through its influence, reminding us that much of our galaxy's true substance remains a mystery. The Milky Way is filled with giant molecular clouds, vast nurseries where new stars are born. These clouds of gas and dust are cold and dark, but within their dense cores, gravity ignites nuclear fusion. From these hidden regions emerge brilliant young stars and planetary systems, continuing the galaxy's cycle of renewal. Globular clusters orbit the Milky Way like glittering swarms of ancient stars. These dense spheres contain hundreds of thousands of stars packed tightly together, many more than 10 billion years old. They are relics of the galaxy's formation, surviving through cosmic upheavals to provide a window into the earliest chapters of galactic history. The galactic center is crowded with stars, nebulae, and intense radiation. It is a chaotic environment where stars are born and destroyed in rapid cycles, illuminated by the energy of Sagittarius A*. Though we live far from this cosmic metropolis, Studying the galactic core reveals the extremes of gravity and creation at the heart of our galaxy. The Milky Way is constantly growing, cannibalizing smaller galaxies that wander too close. Streams of stars arc across the sky, the remnants of these devoured companions. Our galaxy is not a static island, but an evolving giant, shaped by mergers and interactions that continue to build its form over billions of years. The stars of the Milky Way are not evenly distributed, but arranged in layers. The thin disk, the thick disk, the halo, and the bulge. Each of these components has its own population of stars, ages, and chemical compositions. Together they weave a complex history of star formation, migration, and galactic evolution. The Milky Way is threaded with cosmic highways of hot gas and plasma, extending far into intergalactic space. These structures connect the galaxy to the larger cosmic web, channels of matter that link galaxies together. Our home is not isolated, but part of a grand network that stretches across the universe. The night skies. Milky Way band is brightest when we look toward the galactic center in Sagittarius. Here, the combined light of countless stars shines through dusty clouds, producing the glowing river we see from Earth. Ancient peoples across the world named and revered this band, weaving it into myths that connected the heavens to human life. Radio telescopes revealed the Milky Way in wavelengths our eyes cannot see, uncovering structures hidden by dust. These views expose spiral arms, star-forming regions, and the faint glow of gas extending far beyond the visible disk. By looking at our galaxy in many forms of light, we discover its true complexity. The Milky Way is not as massive as some galaxies, yet it is a giant compared to most. With hundreds of billions of stars and a halo extending hundreds of thousands of light-years, it dominates the local group alongside Andromeda. Its scale humbles us, showing that our solar system is a mere speck within a galactic colossus. The motion of stars within the Milky Way is governed by both visible and invisible matter. Stars orbit the center at unexpected speeds, faster than they should if only visible matter existed. This discrepancy is one of the strongest pieces of evidence for dark matter, a reminder that much of our galaxy remains unseen. The stars in the Milky Way are constantly in motion, orbiting the galactic center in intricate patterns. Some stars, especially those in the halo, travel in elongated orbits that carry them far above and below the galactic plane. Their paths reveal the gravitational structure of the galaxy and hint at the ancient collisions that shaped its form. Interstellar dust weaves through the Milky Way like cosmic smoke, dimming and reddening the light of distant stars. Though it obscures our view, this dust is essential, as it provides the raw material for new stars and planets. Each grain is a building block of worlds, formed in the hearts of dying stars and scattered into the galaxy. The Milky Way emits a faint glow in gamma rays, the highest energy form of light. This radiation comes from cosmic rays colliding with interstellar gas, as well as from exotic phenomena like pulsars. The galaxy, in every wavelength, reveals layers of activity invisible to the human eye, painting a portrait of a restless, energetic system. The galaxy's spiral arms are peppered with stellar nurseries, where hot young stars illuminate surrounding gas clouds. Nebulae like the Eagle and the Lagoon shine brightly in these arms, glowing testaments to the ongoing cycle of creation. The spiral arms are not static. They are waves of density, moving slowly and triggering new bursts of life wherever they pass. Some stars in the Milky Way move so fast that they are escaping the galaxy entirely. These hypervelocity stars are flung outward by interactions with the central black hole or close encounters with massive companions. Each runaway carries with it the story of a violent encounter. Speeding into the void between galaxies, the Milky Way hums with radio emissions, including mysterious signals known as fast radio bursts. Though their origins remain uncertain, many are thought to come from extreme stars like Mag. The galaxy speaks across the spectrum, filling space with whispers of its activity for those who know how to listen. Not all stars in the Milky Way were born here. Some were captured from smaller galaxies during mergers and now orbit within our halo or stream across the disk. These immigrant stars carry chemical signatures different from native populations, testifying to the galaxy's long history of cosmic cannibalism. The Milky Way's rotation curve, the speed of stars versus their distance from the center, defies classical physics. Instead of slowing at the edges, stars maintain high velocities, evidence for vast halos of dark matter. The very motion of our galaxy confirms the presence of invisible forces shaping its destiny. Supernova within the Milky Way act as cosmic forges, scattering heavy elements into surrounding space. These explosions enrich the galaxy with the ingredients needed for life, spreading carbon, oxygen, and iron into future generations of stars and planets. Our very bodies are made from this stardust, a gift of long-dead stars. The galactic bulge, a dense concentration of stars at the center, swells outward in a peanut-like shape. This structure, revealed by infrared observations, is thought to be linked to the Milky Way's central bar. The bulge is a crowded, energetic hub, contrasting sharply with the quiet outskirts where our sun resides. The Milky Way is threaded with enormous bubbles of gas and radiation, known as the Fermi bubbles, extending tens of thousands of light-years above and below the galactic plane. These structures are thought to be the result of past outbursts from Sagittarius A*. They reveal that our galaxy's core has a fiery and violent history. The metallicity of stars in the Milky Way varies across the galaxy, with younger stars closer to the disk enriched in heavy elements. Older stars in the halo, by contrast, contain far fewer metals, a reflection of their ancient origins. These chemical differences allow astronomers to trace the timeline of star formation and galactic growth. The Magellanic Clouds, two small satellite galaxies, orbit the Milky Way in a long, complex dance. Their gravity stirs the outer disk, contributing to the warp of our galaxy. Streams of gas stripped from these companions trail across the sky, feeding the Milky Way with fresh material for future star formation. The Milky Way itself is moving, speeding through space at hundreds of kilometers per second relative to the cosmic microwave background. Our galaxy, along with the local group, is being drawn toward the Great Attractor, a mysterious region of concentrated mass. Even the galaxy itself is not stationary, but caught in the flow of cosmic tides. Ancient myths across cultures gave names and stories to the Milky Way, seeing it as a river of souls, a road for gods, or a path of birds. Long before telescopes, humans looked upward and sensed the importance of this celestial river. The galaxy is not only a physical structure, but also a wellspring of imagination and meaning. The central regions of the Milky Way are home to intense starbursts, where stars form at a furious pace. These clusters of newborn stars shine brightly, releasing radiation and winds that shape their The heart of the galaxy is both a place of destruction and of continual rebirth. The Milky Way's thin disk, where our sun resides, contains stars of various ages, but many are relatively young compared to those in the halo. The thin disk is also home to gas and dust, making it the galaxy's primary site of ongoing star formation. It is the bright, visible plane that dominates our view of the night sky. The thick disk, in contrast, contains older stars with lower metal. Its origins remain debated. Some theories suggest it was built through past mergers, while others propose it formed from turbulent gas in the galaxy's youth. The thick disk is a fossil of ancient times, quietly orbiting above and below the thin disk. The Milky Way glows faintly in microwaves due to dust and electrons interacting with cosmic rays. This glow forms a background signal in astronomy, often needing to be filtered out to study the cosmic microwave background. Yet in its hum lies the fingerprint of the galaxy itself, radiating softly across the universe. Our sun is just one of billions of stars in the Milky Way, yet it carries its own unique chemical signature. Studies show that no two stars have exactly the same abundance of elements, making each one a kind of cosmic fingerprint. The galaxy is a vast collection of individuals, each star a story written in light and chemistry. The Milky Way is a barred spiral galaxy, meaning its central stars form a long bar-shaped structure. This bar funnels gas toward the core, fueling both star formation and the activity of the central black hole. Far from being static, the bar is a dynamic feature, constantly shaping the evolution of the galaxy's heart. Star formation in the Milky Way follows a cycle. Cold gas clouds collapse to form stars. Those stars live out their lives, and supernova return enriched material to space. This recycling process ensures that each new generation of stars contains more heavy elements than the last. The galaxy is, in essence, an endless engine of creation. The stellar halo contains ancient stars that date back to the galaxy's earliest days. These stars are poor in heavy elements, indicating they formed before the Milky Way had enriched itself with supernova. They act as living fossils, carrying with them the memory of the galaxy's formation more than 12 billion years ago. The Milky Way is not uniform in brightness. Spiral arms appear brighter because they contain young, massive stars that burn intensely but live short lives. Between the arms, regions are dimmer, filled with older, cooler stars. This contrast gives the galaxy its iconic pinwheel appearance when seen from afar. Cosmic rays stream through the Milky Way, accelerated by supernova explosions and magnetic fields. These high-energy particles bombard planets, affect atmospheres, and even influence cloud formation on Earth. Our galaxy is not silent but alive with invisible streams of energy crossing vast distances. The disk of the Milky Way is about 1,000 light-years thick, a relatively thin layer compared to its 100,000 light-year span. Within this disk lies the majority of stars, gas, and dust. Our solar system, nestled inside, rides along within this thin, radiant plane of galactic life. The galactic halo extends far beyond the visible disk, reaching perhaps 300,000 light-years into space. Though faint, it holds immense amounts of dark matter, as well as ancient globular clusters. It is the unseen foundation of the Milky Way, providing the mass that binds the galaxy together. The Milky Way is threaded with spiral density waves, which move through the disk and concentrate material. These waves compress gas and trigger star formation, shaping the structure of the arms. Without them, the galaxy might appear as a formless cloud, rather than the graceful spiral we recognize today. Supermassive black holes like Sagittarius A** are common in galaxies, but the Milky Way's is relatively quiet. Occasionally, flares of radiation erupt as it consumes bits of gas or dust, but compared to quasars, it is subdued. Its calmness may be part of why life was able to thrive in our corner of the galaxy. The stars in the bulge follow orbits that are not aligned with the rest of the disk. Their chaotic paths give the bulge its puffed-up shape, distinct from the organized rotation of the spiral arms. This contrast reflects the galaxy's complex history of growth and collisions. The Milky Way is tilted relative to the plane of the solar system. When we look up at the night sky, the glowing band arcs at an angle, reminding us that our tiny system is just one layer in a much larger structure. The tilt offers a constant visual reminder of our place in the galaxy. Dust lanes thread through the spiral arms, appearing as dark streaks against the bright background of stars. These dusty regions block visible light but glow in infrared, where they reveal their true structure. They are both obstacles to starlight and wombs of creation, hiding young stars within their shadows. The Sun orbits the galactic center at about 828,000 kilometers per hour. At this speed, it still takes more than 200 million years to make a single orbit. We live in a cosmic journey where even the simplest circle spans timescales far beyond human comprehension. The Milky Way produces a diffuse glow of X-rays from hot gas, supernova remnants, and energetic stars. These high-energy emissions form a hidden portrait of the galaxy, showing the violence and intensity of processes otherwise invisible. Every wavelength of light tells a different chapter of the Milky Way's story. Stellar streams lace the halo, remnants of smaller galaxies torn apart by the Milky Way's gravity. These streams of stars arc gracefully across the sky, testimony to ancient mergers and ongoing growth. They are the fossils of cosmic cannibalism, marking the scars of galactic evolution. The outer regions of the Milky Way are still being mapped, revealing extended arms and structures faintly glowing at the edge of visibility. These outskirts connect the galaxy to the wider cosmic web. They remind us that the Milky Way has no sharp boundary, but fades gradually into intergalactic space. Star clusters are abundant in the Milky Way, ranging from small open clusters of young stars to massive ancient globular clusters. Each cluster is a family born together, moving as a group through the galaxy. They are the building blocks of stellar populations, offering insight into the conditions of their birthplaces. The galaxy's gravitational pull binds not only stars and gas, but also hundreds of billions of planets. These worlds orbit in every imaginable configuration, from searing hot gas giants to icy rogue planets. The Milky Way is a cradle not just of stars, but of countless potential homes. The motion of the Milky Way relative to other galaxies produces blue and red shifts in their light. By studying these shifts, astronomers map the galaxy's place in cosmic flows. Our galaxy is one part of a vast river of motion, drawn toward massive structures far beyond our sight. The Milky Way shines at an absolute magnitude of around -21. making it brighter than most galaxies, but dimmer than the largest ellipse. It is a middleweight giant, powerful enough to dominate its region, but not the most massive in the universe. In cosmic terms, it is both extraordinary and ordinary. The Milky Way has an age gradient, with stars in the center generally older than those in the spiral arms. This pattern reflects how the bulge formed quickly in the galaxy's youth, while the arms continue to create new stars today. It's a layered history, with time itself etched into the structure of the galaxy. Radio waves map the Milky Way in a way that visible light cannot, cutting through dust to reveal its full spiral structure. Pulsars, masers, and gas clouds broadcast radio signals that sketch a hidden portrait of our galaxy. Without radio astronomy, much of the Milky Way's true shape would remain unknown. The central bar of the galaxy is about 27,000 light-years long, cutting across the core like a cosmic spine. Stars stream along it, and gas flows inward, feeding star formation. It is a backbone of sorts, both stabilizing and shaping the living heart of the Milky Way. In addition to stars, the Milky Way contains vast amounts of molecular clouds, the raw material for star formation. These cold, dense clouds are invisible to the eye, but glow in millimeter and infrared light. They are the hidden reservoirs of creation, fueling the galaxy's ongoing renewal. High above the galactic plane, the Milky Way emits gamma rays from cosmic ray interactions. These gamma rays trace invisible processes of energy exchange, shock waves, and decays of exotic particles. The galaxy glows not only in gentle starlight, but also in violent, high-energy fireworks. The Milky Way is surrounded by dark matter, an unseen halo far more massive than the visible galaxy. This dark matter provides the gravitational glue that keeps stars in their orbits. Without it, the galaxy would simply fly apart, revealing how much of our universe remains hidden from direct view. The Sun's orbit around the galaxy is not a perfect circle, but a wavy path that carries it above and below the galactic plane. This vertical oscillation takes tens of millions of years, producing a gentle bobbing motion. Our solar system moves not only forward but up and down, like a ship riding galactic tides. The Milky Way has giant bubbles of hot gas extending 25,000 light-years above and below the galactic plane. Known as the Fermi bubbles, they may have formed from past eruptions of Sagittarius A*, or massive starbursts. They are colossal scars, still glowing faintly in gamma rays and X-rays. The galaxy's metallicity varies across regions, with stars closer to the center generally richer in heavy elements. This is because star formation has been more intense there, recycling material faster. In contrast, stars in the outskirts are more primitive, carrying the chemistry of earlier cosmic times. The Milky Way is part of the cosmic web, a vast structure of filaments and voids made of dark matter and gas. It sits on one thread of this web, connected to others by faint streams. The galaxy is therefore both a world unto itself and a node in the grand architecture of the universe. Infrared surveys reveal countless stars hidden by dust, doubling or tripling estimates made by visible light observations. This shows how much of the galaxy is concealed from the naked eye. The Milky Way is always more than it seems, a vast structure hiding behind veils of shadow and light. Globular clusters orbiting the galaxy act like satellites, each containing hundreds of thousands of ancient stars. Their orbits trace arcs far above and below the galactic plane, showing the reach of the Milky Way's gravity. They are relics, remnants of an era when the universe itself was young. The galaxy is not a rigid structure but a constantly evolving one. Spiral arms shift, gas clouds collapse, stars drift, and the halo absorbs new material. The Milky Way is more like a living organism than a static sculpture, reshaping itself across cosmic time. The rotation curve of the Milky Way reveals that stars at different distances from the center move at nearly the same speed. This defies Newtonian predictions and was one of the key clues to the existence of dark matter. The galaxy whispers secrets of hidden mass through the simple motion of its stars. The Milky Way's disk is warped, with its edges bent like a vinyl record left in the sun. This warp may be caused by interactions with the Magellanic Clouds or the pull of dark matter. It shows that galaxies are not flat but flexible, bending under the invisible forces of their environment. Star-forming regions in the Milky Way often emit brilliant nebulae, glowing with ionized gas from young, hot stars. These nebulae mark the cradles of creation, scattered like jewels across the spiral arms. They remind us that the galaxy is constantly birthing new suns. The chemical fingerprints of stars in the Milky Way reveal its merger history. Some stars carry chemical signatures unlike others, proof that they were born in galaxies long since absorbed. Each star is a storyteller, and together they recount a tale of cosmic cannibalism. The galactic center is veiled by thick dust, invisible light, but infrared and radio telescopes can pierce this veil, revealing stars orbiting the black hole. What seems like darkness to our eyes is, in truth, one of the most crowded and energetic regions of the galaxy. The Milky Way may be part of a larger galactic plane of satellites, with dwarf galaxies and streams aligned in a vast sheet. If true, this challenges current models of galaxy formation. It suggests that our galaxy is shaped not only by randomness, but by larger patterns in the cosmos. The galaxy's future includes a collision with the Andromeda Galaxy, an event that will reshape both into one larger elliptical galaxy. Though the stars themselves will rarely collide, their orbits will be thrown into chaos, and new structures will emerge. The Milky Way is not eternal. It too will transform. The Milky Way is surrounded by a diffuse corona of hot ionized gas, stretching hundreds of thousands of light-years into intergalactic space. This corona holds more mass than all the stars in the galaxy combined, yet it is nearly invisible, detectable only through X-rays and absorption lines. It is a hidden ocean in which our galaxy swims. Stellar populations in the Milky Way are classified into distinct groups. Population I stars are young and metal-rich, found in the disk, while population II stars are older and metal-poor, residing in the halo. These groups reflect the galaxy's layered history, each generation built on the ashes of the last. The galaxy contains more than 400 billion stars, though estimates vary widely depending on assumptions about faint red dwarfs. Many of these stars are too dim to see without telescopes, but together they weave the tapestry of the night sky. Each star is a tiny light in a vast, interconnected whole. Microlensing events, where a star's gravity briefly magnifies a more distant star, allow astronomers to study dark objects in the Milky Way. These events reveal planets, black holes, and faint stars otherwise invisible. Gravity itself becomes a tool for uncovering the unseen architecture of the galaxy. The spiral arms of the Milky Way are not fixed structures, but regions of density that move like traffic jams along a highway. Stars and gas flow through them, lighting them up as they compress and form new stars. The arms are temporary, dynamic features, constantly shifting over cosmic time. The galactic center radiates strong emissions from molecular clouds, masers, and magnetic fields. It is a hub of activity, where dense gas collides, stars crowd together, and energy bursts outward. To peer into this region is to glimpse the galaxy's beating heart. The Milky Way is constantly bombarded by material from intergalactic space, including streams of hydrogen gas falling onto its disk. This fresh supply of fuel sustains ongoing star formation, ensuring that the galaxy does not exhaust its reserves. The galaxy grows by both consuming and replenishing. The Sun resides in the Orion Arm, a minor spiral arm sometimes called a spur. This location places us between the larger Sagittarius and Perseus arms. From here, we see the Milky Way as a great band, but in truth, we live in a small tributary of the galactic river. The chemical enrichment of the Milky Way has allowed for the formation of complex molecules, including organic compounds. These molecules float in clouds, some resembling the building blocks of life. The galaxy is not only a factory of stars, but a chemistry lab, testing recipes for biology. The thick disk of the Milky Way contains older stars than the thin disk, and its origins remain debated. Some believe it formed through mergers, while others argue it arose from turbulent gas in the galaxy's youth. It is a fossil layer, recording an era of violence and rapid change. The galactic warp shifts not only the outer disk but also the gas and dust, affecting how stars form in the outskirts. It is a ripple frozen in starlight, a reminder that the galaxy's shape is influenced by forces both internal and external. Even the stars ride on invisible waves. The Milky Way emits a faint background glow known as the cosmic infrared background, produced by countless stars and dust clouds. This glow is invisible to the naked eye, but detectable with sensitive instruments. It is the collective whisper of billions of suns. Blending into a single light, hypervelocity stars race through the galaxy at thousands of kilometers per second, ejected by interactions with the central black hole or other massive systems. These stars move fast enough to escape the galaxy entirely, flung into intergalactic space. They are cosmic exiles, carrying the Milky Way's signature into the void. The satellite galaxies of the Milky Way are slowly being stripped of stars by tidal forces. Streams like those from the Sagittarius dwarf stretch across the sky, adding to the halo. The Milky Way feeds on its neighbors, and their remnants become part of our galactic family. The galaxy's star formation rate is about 1 to 2 solar masses per year. This means that somewhere in the galaxy, new stars are born nearly every day. Though the process is invisible from Earth, the Milky Way is always renewing itself, never truly still. The Milky Way's motion is influenced by the Great Attraction, a massive region of space filled with galaxies and dark matter. This pull tugs on our galaxy, drawing it slowly toward a distant point. The Milky Way is not isolated, but part of a larger flow of cosmic currents. The halo of dark matter around the Milky Way may extend far enough to overlap with that of Andromeda. If so, the two galaxies are already connected by invisible bridges of mass. Their future collision is already written in their shared gravitational bond. The disk of the Milky Way contains patterns called spiral spurs, short offshoots of the main arms. These spurs, like the Orion arm we live in, are filled with stars, nebulae, and planets. They are smaller tributaries in the Great Spiral River, home to countless worlds. The Milky Way's influence reaches far beyond its stars, shaping the orbits of comets in the Oort cloud surrounding the solar system. Galactic tides can disturb these distant icy bodies, occasionally sending them toward the inner solar system. The galaxy touches even the farthest edges of our own home. When we look at the night sky, every star we see with the naked eye belongs to the Milky Way. Other galaxies, like Andromeda, appear as faint smudges. The stars that glitter above us are just a tiny fraction of our own galaxy's vast population, a reminder of the immensity that surrounds us. The story of the Milky Way is not only one of stars and gas, but of time itself. From its violent birth, through mergers and starbursts, to its tranquil present and eventual collision with Andromeda, it is a living narrative unfolding across billions of years. To study the Milky Way is to read our galaxy's autobiography, written in light, dust, and gravity. The Milky Way is home to some of the fastest spinning pulsars ever recorded, with rotation rates of hundreds of times per second. These stellar remnants are like cosmic lighthouses, beaming regular pulses across space. Their stability allows astronomers to use them as precise galactic clocks. The interstellar medium of the Milky Way is not uniform but clumpy, with dense clouds of gas and dust scattered among empty voids. These clumps determine where stars can form, creating pockets of life within a vast sea of emptiness. The galaxy is textured, its matter unevenly distributed like a cosmic patchwork at the core of the Milky Way. Stars orbit Sagittarius A** at incredible speeds, some completing full orbits in just a few years. Watching their paths provides direct evidence of the supermassive black hole's gravity. These S-stars are proof that unseen giants anchor the galaxy. The Milky Way hosts superbubbles, enormous cavities in the interstellar medium carved by multiple supernovae. These bubbles can stretch hundreds of light-years across, filled with hot, thin gas. They are cosmic scars, reminders of stellar violence that reshaped their surroundings. Interstellar dust in the Milky Way polarizes starlight, twisting its orientation as it passes through magnetic fields. This effect lets astronomers trace invisible lines of force threading the galaxy. The light we see is subtly altered by the magnetic skeleton of the Milky Way. The thick disk contains stars with orbits, inclined at steeper angles than those in the thin disk. These orbits carry them higher above the galactic plane, forming a puffier distribution. Their presence points to ancient upheavals that stirred the galaxy in its youth. Stars in the halo often follow eccentric orbits, plunging in and out of the galactic disk like comets. Their paths carry them through the core and back into the outer reaches, creating a dynamic dance. These travelers knit together the inner and outer galaxy. The Milky Way radiates diffuse synchrotron emission, caused by electrons spiraling around magnetic fields. This faint glow in radio wavelengths paints a portrait of invisible energy coursing through the galaxy. It is a reminder that even empty space hums with activity. Molecular clouds in the Milky Way often display filamentary structures, stretching across tens of light. These filaments act like highways along which material collapses into stars. The galaxy sculpts itself into intricate shapes, where gas arranges into threads of creation. The inner halo of the Milky Way is more spherical, while the outer halo appears elongated. This shape difference may result from mergers with dwarf galaxies. The halo's geometry records the story of collisions, written in the faintest starlight. The bulge of the Milky Way contains a population of red clump giants, stars used as standard candles to measure distances. These stars shine with nearly uniform brightness, acting as markers in the crowded core. They allow astronomers to chart the shape of the galaxy's center. Some regions of the Milky Way glow with maser emissions, where molecules amplify radio waves like natural lasers. These cosmic masers mark star-forming regions and can be detected across vast distances. They are the galaxy's own beacons, broadcasting the presence of newborn stars. The disk of the Milky Way is laced with spiral spurs filled with bright nebulae. The Orion Spur, our home, contains famous regions like the Orion Nebula and the Eagle Nebula. Even in a minor arm, the galaxy fills space with wonders of creation. The stars of the Milky Way move not only around the core, but also relative to one another, producing streams and clumps. These moving groups preserve the memory of the clusters they were born in. Though scattered, their motions reveal their common origins. The galaxy has chimneys, vertical structures where supernova blast hot gas out of the disk. These chimneys vent energy into the halo, connecting the inner regions to outer space. The Milky Way breathes through these channels, cycling matter in great cosmic size. Interstellar dust grains in the Milky Way are coated with icy mantles containing frozen water, carbon dioxide, and methane. These ices harbor chemistry that may eventually seed planets. Even in the coldest corners, the galaxy prepares the ingredients for life. The magnetic field of the Milky Way aligns over scales of thousands of light-years, threading through arms and clouds alike. Though invisible, it exerts real influence, guiding cosmic rays and shaping star formation. It is the hidden scaffolding of the galaxy. Star counts revealed that the central bulge is shaped not like a sphere, but like a peanut or box. This odd structure arises from the buckling of the bar, giving the galaxy a unique silhouette. From afar, the Milky Way's heart would appear swollen and angular. The galaxy's outskirts contain flaring, where the disk thickens at greater distances. This flaring reflects the weaker pull of gravity on the outer stars. The Milky Way's edges are not sharp but diffuse, fading gradually into the void. The Milky Way contains ring-like structures, such as the Monoceros ring, a faint stellar overdensity encircling the disk. These rings may be remnants of dwarf galaxies torn apart. They are echoes of past feasts, looping around the galactic plate. The Milky Way emits faint radio waves from neutral hydrogen gas, detectable at 21 centimeters. This hydrogen line has been a crucial tool for mapping the galaxy's spiral arms. Through this frequency, the Milky Way speaks, revealing its structure to those who listen. Young star clusters in the Milky Way dissolve within hundreds of millions of years, their stars scattering across the disk. Though short-lived, these clusters enrich the galaxy with diverse stellar populations. Each family disperses, yet its members remain part of the galactic whole. The galaxy contains chimera stars, objects that appear enriched with elements borrowed from companions. Mass transfer in binary systems alters their composition, giving them mixed identities. The Milky Way is filled with stars carrying the fingerprints of others. The farthest reaches of the Milky Way's halo may host rogue planets ejected from systems. These lonely worlds drift in darkness, bound only by the galaxy's gravity. They are silent wanderers, countless in number, tracing unseen paths through the void. The Milky Way has regions known as superbubbles that merge into soup bellies, spanning thousands of light-years. These vast arcs of gas glow faintly in radio light. They are the largest structures sculpted by the death of stars. Tidal streams from merging galaxies wrap around the Milky Way like ribbons. These arcs preserve the orbital paths of their lost homes. The galaxy is a collector, weaving others into its own vast tapestry. The Milky Way star formation is uneven, with bursts triggered by collisions or gas inflow. Some regions blaze with activity, while others lie dormant. The galaxy's rhythm is irregular, pulsing with creation in fits and starts. The inner disk rotates faster than the outer regions, producing shear that stretches clouds into elongated shapes. This shear sculpts the interstellar medium into spirals and arcs. Motion itself becomes an artist, shaping the galaxy's face. Micrometeorites reaching Earth often contain isotopic signatures, linking them to ancient supernovae in the Milky Way. These grains are physical relics of stellar explosions billions of years old. We carry dust from long-dead stars within our planet. The galaxy's center harbors stars packed 1,000,000 times more densely than in our neighborhood. In that crowded environment, stellar encounters are common, leading to collisions and exchanges. Life there would exist under an entirely different night sky, crowded with dazzling suns. The Milky Way rotates like a giant wheel, but its spiral arms trail behind as density waves. This lag creates the pattern of compression and release that fuels starbirth. The arms are both sculptors and byproducts of motion. In the far future, the Milky Way's stars will fade as fuel is exhausted. The galaxy will dim, its arms dissolving into a faint haze of cooling remnants. Even galaxies are mortal, destined to fade into the long night of the cosmos. Starburst regions in the Milky Way can form stars at rates far higher than average. These localized bursts create clusters and massive young stars that quickly enrich their surroundings. They are short-lived flares of creativity in the galaxy's long life. The Milky Way's gravitational pull extends to dwarf galaxies orbiting hundreds of thousands of light-years away. These satellites dance around us, some bound to crash inward eventually. The galaxy's family is large, though not all members will last. Planetary nebulae scattered across the disk mark the gentle deaths of medium stars. Their glowing shells add color and complexity to the interstellar medium. These delicate structures are the galaxy's quiet farewells. The Milky Way is home to stars more than 13 billion years old, nearly as old as the universe itself. These survivors are fossils, carrying the chemistry of the primordial cosmos. They link us directly to the dawn of creation. Dust in the Milky Way not only blocks light but scatters it, producing reddening effects that make stars appear warmer. Correcting for this reddening allows astronomers to measure distances more accurately. Dust both hides and reveals the truth. The galaxy's future merger with Andromeda will trigger waves of star formation as gas clouds collide. The night sky will fill with brilliant arcs of stars, though Earth may not survive to witness it. The Milky Way's destiny is transformation. At the far edge of the Milky Way, the gravitational grip loosens, allowing some stars to escape into intergalactic space. These escapees carry the memory of their origin, but live as wanderers. The galaxy is not a closed system, but a porous one. The stellar halo is populated not only by stars but also by faint brown dwarfs and white dwarfs. These remnants contribute unseen mass, invisible without careful searches. The galaxy's outskirts hide a cemetery of faint, forgotten suns. The Milky Way glows faintly in microwave light, a byproduct of free electrons scattering photons. This emission adds to the cosmic background, blending the galaxy's voice with that of the universe. It is a quiet hum beneath the louder signals of starlight. The bar at the center of the galaxy rotates, carrying stars and gas along with it. This rotation redistributes material, shaping the spiral arms and fueling activity in the core. The bar is not fixed but alive, moving the galaxy's heart. Some dwarf galaxies orbiting the Milky Way show signs of being stripped into streams, but still resist full absorption. These galaxies exist in a twilight state, partly destroyed yet partly whole. They embody the slow violence of galactic interactions. The chemical diversity of the Milky Way is immense, with stars containing unique blends of elements forged in countless supernovae. No two stars are identical in composition. Each one is a record of past explosions, a unique page in the galaxy's chronicle. The Milky Way is not static but rotates at extraordinary speeds. Stars near the Sun orbit the galactic center at about 828,000 kilometers per hour, completing a revolution every 225 to 250 million years. Despite these speeds, we feel nothing, because the whole solar system is carried along in this grand motion. Our galaxy has a stellar bar running through its center, composed of densely packed stars and gas. This bar channels material inward, fueling star formation and feeding the supermassive black hole. It is both a highway and a funnel, shaping the evolution of the inner regions. The Milky Way's spiral arms are traced not only by stars, but also by giant molecular clouds. These immense collections of gas and dust act as stellar nurseries, glowing in radio and infrared light. Their positions map out the invisible structure of our galaxy's skeleton. Although we imagine the Milky Way as a flat disk, its thickness is remarkable. roughly 1,000 light-years for the thin disk and 3,000 for the thick disk. Within these layers, stellar populations differ in age and chemistry, reflecting the galaxy's layered past. The metallicity gradient of the Milky Way shows that stars near the center are richer in heavy elements than those in the outskirts. This is because star formation has been more intense and long-lived in the central regions, enriching the interstellar medium over billions of years. The Magellanic Clouds, two of the Milky Way's largest satellite galaxies, are bound in a gravitational dance with our own. Streams of gas called the Magellanic Stream trail behind them, feeding our galaxy with fresh hydrogen and shaping the halo. Gamma ray bubbles discovered above and below the galactic center extend tens of thousands of light-years. These Fermi bubbles are evidence of a past outburst from the central black hole or intense bursts of star formation, revealing that the Milky Way's core has flared in the past. The stars of the halo move differently than those in the disk, often on highly elliptical orbits. Many of these halo stars originated in smaller galaxies consumed by the Milky Way, leaving them as living fossils of cosmic cannibalism. Open clusters, groups of stars born together, dot the disk of the Milky Way. They eventually dispersed as their stars drift apart, but while they last, they act as laboratories for studying stellar evolution and the dynamics of young stars. The thick stellar streams that thread across the halo are the remnants of galaxies torn apart by tidal forces. Each stream is a scar of past mergers, written across the sky as trails of stars still following their original paths. The Milky Way's total luminosity is about 10 billion times that of the Sun, though spread across hundreds of billions of stars. From afar, our galaxy would appear as a glowing spiral jewel, radiating light that tells the story of its stars' lifetimes. Stellar flares from red dwarfs, the most common type of star in the galaxy, can influence the habitability of their planets. These stars may be dim, but their volatile natures inject energy and danger into surrounding systems, shaping the galaxy's planetary environments. The oldest stars in the Milky Way may be nearly as old as the universe itself, exceeding 13 billion years. These stars preserved the chemistry of the early cosmos, formed before many of the heavier elements existed. They are time capsules glowing faintly in the halo. Massive star clusters near the galactic center are packed so densely that stars are only light days apart. These regions are chaotic, with intense radiation, strong winds, and frequent stellar collisions, creating an environment unlike anywhere near the Sun. The galactic disk ripples not only from interactions with satellites, but also from the motion of dark matter clumps. As invisible structures pass through, they leave behind waves in the disk, altering its shape like stones dropped in water. Stellar feedback winds, supernova, and radiation sculpts the Milky Way's gas into bubbles and shells. These structures regulate star formation, preventing gas from collapsing too quickly. The galaxy maintains balance through destruction as much as creation. The Sagittarius A** black hole is not always quiet. Flares of X-rays and radio waves are observed, sometimes multiple times a day. These events occur when clumps of matter fall too close, briefly lighting up the darkness before vanishing beyond the event horizon. The farthest outskirts of the Milky Way may contain faint streams and structures we have yet to map. As surveys grow more detailed, new tendrils of stars are discovered, revealing that our galaxy's halo is more complex and sprawling than once believed. The bulge of the Milky Way contains stars on chaotic, boxy orbits, giving it a peanut-like shape when viewed from certain angles. This unusual geometry arose from instabilities in the bar, reshaping the very core of the galaxy. Supernova remnants enrich the galaxy with heavy elements, scattering carbon, oxygen, iron, and more into space. Without this cycle of death and rebirth, planets and life itself could never form. The Milky Way is constantly seeded by the ashes of exploded stars, globular clusters orbiting the Milky Way number around 150 each, containing hundreds of thousands of stars. Many of these clusters are among the oldest structures in the galaxy, relics from the dawn of its history. The interstellar medium is not evenly distributed but forms vast cavities and bubbles. Some of these voids are carved by supernova, while others result from winds of massive stars. The Sun itself resides in such a region, called the local bubble. Microwave emissions from spinning dust grains in the Milky Way create a faint glow across the sky. These emissions complicate observations of the cosmic microwave background, but also revealed the galaxy's dusty components in exquisite detail. The galactic plane is so crowded with dust that entire regions of the Milky Way are hidden from visible light. Infrared and radio observations pierce this shroud, unveiling star-forming regions and hidden clusters otherwise invisible to human eyes. The Milky Way's disk hosts a Bohr-spiral hybrid structure, blurring the lines between barred and classical spirals. This dual identity reflects the complex dynamics shaping our galaxy, where gravity, rotation, and density waves weave together. The central molecular zone near Sagittarius A** is one of the richest star-forming environments in the galaxy. Clouds here are denser and more turbulent than elsewhere, producing some of the most massive and extreme star clusters in existence. The dark matter halo of the Milky Way stabilizes the galaxy's rotation, preventing its stars from flying apart. This unseen mass outweighs visible matter by a factor of 5, dominating the galaxy's fate, even though it cannot be directly observed. The disk of the Milky Way is not isolated but threaded by magnetic fields. These fields align dust grains, influence cosmic ray propagation, and shape the dynamics of the interstellar medium, adding an invisible structure to the galaxy's design. The stellar halo is laced with carbon-enhanced metal-poor stars, relics of the earliest nucleosynthesis. These stars contain signatures of the first supernova, preserving the fingerprints of the universe's earliest explosions. Tidal debris from past mergers can be traced not only in stars but also in gas. These gaseous streams reveal the hidden scars of galactic cannibalism, showing how the Milky Way has consumed and absorbed its neighbors over time. The Sun's orbit through the Milky Way may influence Earth's climate on long timescales. As the solar system moves through dense regions of the galaxy, cosmic ray fluxes increase, potentially impacting atmospheric chemistry and even life's evolution. The star-forming ring around the galactic bar, called the 4 kiloparsec ring, is one of the most productive nurseries in the Milky Way. Here, molecular clouds pile up and collapse, birthing generations of stars in bursts of creation. The thick disk may have formed after a violent merger billions of years ago, when a smaller galaxy collided with the Milky Way. This event heated and puffed up the disk, leaving behind the distinct population of stars we see today. The mass of the Milky Way is still uncertain, with estimates ranging from 800 billion to 1.5 trillion solar masses. This uncertainty arises because much of the mass is dark matter, invisible to direct measurement, yet essential to the galaxy's structure. The Andromeda Galaxy and Milky Way already exchange material through tidal interactions. Stars and gas flow between their halos, suggesting that their eventual merger has already begun in a subtle, invisible way. The Milky Way emits synchrotron radiation, generated by cosmic rays spiraling through magnetic fields. This radiation glows in radio wavelengths, providing clues to the galaxy's energetic particles and magnetic structure. The Oort cloud, at the edge of the solar system, may be influenced by the Milky Way's tides. Passing through spiral arms or encountering molecular clouds could jostle comets inward, sending icy wanderers toward the Sun and Earth. The bulge contains stars with a wide range of reflecting both ancient and more recent star formation. This diversity suggests a complex history of growth, enriched by multiple waves of creation and collapse. Infrared surveys have revealed thousands of previously hidden star clusters in the Milky Way, obscured by dust. These discoveries highlight how incomplete our picture of the galaxy remains. Even though we live within it, the galactic warp shifts over time, precessing as the disk and halo interact. This slow twisting motion shows that the Milky Way's shape is not fixed but evolves. Under the influence of both visible and invisible forces, the interstellar dust that obscures much of the Milky Way also scatters and reddens starlight, a phenomenon known as extinction. By studying this effect, astronomers can map dust distribution and better understand the galaxy's structure. The stellar streams in the halo not only trace past mergers but also help map dark matter. By observing how these streams are distorted, astronomers can infer the invisible mass shaping their paths. The Milky Way is surrounded by an extended stellar halo that may stretch farther than 300,000 light-years. This vast structure contains ancient stars and debris from past collisions. Blending our galaxy into the intergalactic medium, radio telescopes have revealed giant loops and filaments of gas rising from the galactic plane. These enigmatic structures may be linked to magnetic fields or past eruptions from the center. their origins still under investigation. The Milky Way's chemical evolution has steadily increased the abundance of heavy elements, enabling the formation of rocky planets. This enrichment ensures that newer generations of stars are accompanied by more complex planetary systems. Star-forming regions in the Milky Way often produce clusters with massive, short-lived stars. These giants quickly explode as supernovae, enriching their surroundings and triggering new rounds of star birth in a cycle of renewal. The Milky Way is unique to us because it is our home, but galaxies like it are common throughout the universe. By studying others, astronomers learn more about our own, finding echoes of its structure and history written across the cosmos.